Okay, so let's start with the uh, hierarchical clustering. This is a different type of clustering, as the name suggests, hierarchical clustering. Earlier we did it k-means clustering. Now we are talking about the hierarchical clustering. So again, let us clear all that outputs that were there. So clear output, and then we will start our exercise. So it is cleared. Now importing all the required libraries, that is pandas, numpy, matplot. These are the basic libraries every time you need it, so we can run it. And then we are going to import the data set, which is also important. Without that nothing will happen. So we have the wholesale customers data dot CSV. CSV is a comma separated values, and this data is to be imported into this in a data frame called DF. And now we are going to see the 5 top records. So after importing, we'll see that. So this is how the data has been imported, and we are also seeing the various variables, that is channel, region, fresh, milk, grocery. These are the items, features, frozen, detergents, paper, and delicatessen, and things like that. So these are the 5 top records that we have seen. Now here there are multiple product categories. Now these are all different products: grocery item, milk item, fresh items, frozen items, like that. So fresh milk, grocery, etc. The values represent the number of units purchased by each client for each product. Our aim is to make clusters from this data that can segment similar clients together. So our idea is to cluster, to group, to form the groups of the customers who are purchasing the same item. So that means, so that we can know that how many people are buying this particular product and how many are buying the other products, and like that. So that is what our objective is. So we will of course use hierarchical clustering here for this problem. But before applying hierarchical clustering, we have to normalize the data so that the scale of each variable is the same, which is very important, right? So this is the way we can go for it. Now we can run this. Of course nothing will happen here because they are all remarks. So let's first normalize the data and bring all the variables to the same scale. That is important, so that we start from a one base. Now we are going to run this also here in this from sklearn pre-processing, because we have to because we are bringing it at the same scale, so we have to pre-process it. And import normalize. So we are using the normalize, which is a sub library of the sklearn. Then now df scaled. Now we are scaling it. Normalize df data frame, df scaled, pd is the pandas data frame, df scaled, column is equal to df dot column. Whatever columns are there, all of them are to be scaled, and df scaled head. And then we are going to get our top 5 records after scaling it. So this is how you can do that. So we run that, and we have got this all these the same set of data, but in a reformatted manner. So you can see that channels, region, fresh, milk, all these things have been slightly rescaled as per our normalization, as per the codes given here. Now here we can see that the scale of all the variables is almost similar, because if you can see, similar means that they are all similar type of data. Now that is what the purpose is. So now we are good to go. Let's first draw the dendrogram. This is another type of graph which we are going to create to see that whether it has been scaled or not. So to help us decide the number of clusters for this particular problem. So that is what this particular dendrogram is going to tell us. So we can run that. Nothing will happen here. So import scipy dot cluster hierarchy as SHC. This is the name that we have given to this particular type of library that we are importing. Then PLT figure fixed size 5,3, PLT title dendrograms. This is the type of graph that we want, and name of course it is to be given. Then DEND is the name of the of course variable, and SHC dendrogram is the name of the graph. SHC linkage, DF scaled method is word. So we can run that, and we can see that after running, when the process is complete, we will get the outcome. So this is a slightly longer process, it takes little time. Let's wait for a while. Oh yeah, so now we can see that we have got a basic dendrogram, and these are the types of clusters that have been created that we are seeing here. Now as per the that code that we have written, that import scipy.cluster hierarchy as SHC, PLT figure 5353 is the size of the graph, dendrogram is the name of the title of the graph, DND is the variable where we are storing it, SHC dendrogram is the name of the graph, linkage of DF scaled, and method is word. So we have got this kind of a dendrogram. Now the x-axis contains the samples, that is what, in fact it is overwritten like this, so it is not visible, but yes, it is a sample, and y-axis represent the distance between these samples. So here we are getting the distances. Now the vertical line with maximum distance is the blue line, like this. This is the distance that we are getting. All these things, all these small distances that we have, and the bigger distance that we, all of them are available to us, and that is how the hierarchy gets created. The vertical line with the maximum distance is the blue line, and hence we can decide the threshold of 6 and cut the dendrogram. So we can say that we can create 6 dendrograms with this, right? Now we are going to create a dendrogram again with this code, that is PLT figure fixed size 5,3, PLT title dendrogram, again the same code which we have seen earlier, PLT AXH line, y is equal to 6, color R, and line style is dash. So you can run it, and again you can see that we are going to get another dendrogram with the help of this code that we have just written. Yeah, so now it has come. So we can see that the dendrogram has been created, and now this red dash line is also available, which we have mentioned here, like line style is equal to dash, color is red, and then the PLT AXH line, that means this is the line we want to draw at the 6, y is equal to 6, right? So this is how you can get your dendrogram, which is created with the help of the same data which is available to us. Now we have the 2 clusters as this. Now we have got the, broadly if you see, we have got 2 clusters, as this line cuts the dendrogram at 2 points. Let's now apply hierarchical clustering for 2 clusters, right? So we can just run that, nothing will happen here. Again from sklearn import agglomerative clustering. Now this again is a library available in the sklearn sub-library as a cluster. Then cluster is equal to agglomerative clustering, n cluster is equal to 2, because here we have got 2, affinity is Euclidean, and linkage is equal to word. Now this is a type of the linkage between the 2 clusters, so that is why it is given as word. And cluster fit predict DF scale. So now again we run this. Now on running we are getting a kind of array. So all the data that we have is now available to us in the form of an array, right? So this is the array that we have got. Now we can see the values of zeros and ones in the output. Since we defined 2 clusters, 0 represent the points that belong to the first cluster, and 1 represent the points in the second cluster. So that is why complete picture is available to us. So we can run this also, and then nothing will happen of course here. But now we can again create a plot, figure 5.3, scatter plot, milk and grocery and cluster labels. So we can run that, and once we run it, because we have taken only 2, so that is why we have got only the two factors only, right? And these are your milk and grocery. So color is cluster labels, and then this is the way that we have got this. So this is how you can create the clusters. We can see from the graph itself that how many people, how many customers are buying this milk and how many customers are buying groceries. This is how we can create the clusters, right? So you can see from this itself that hierarchy clustering is a super useful way of segmenting observations. The advantage of not having the predefined number of clusters gives it the quite an edge over the K-means cluster. So you can see that this type of clustering becomes very helpful, because if you have huge amount of data, now here we are having a very small size of data, but suppose you have a huge amount of data and you don't know what to do, and you want to get this information also. So you can use this kind of a method and generate your clusters of your customers or whatever type of data you have. Again, you can create the present working directory. Of course, this is something which you know already. So this completes your hierarchical clustering. Thank you.